Good night, everyone. The group is conformed by Tello Oñate and Daniel Sanchez. Now we're going to talk about the three-phase bidirectional AC-AC controller. The next slide. As we can see here, we can see all the circuit. We can see the three-phase neutral line voltage, three-phase of load. Each resistor has 10 ohms, and the firing angle is 75 degrees. So as we can see, the circuit is controlled by thyristor, and each phase with and each thyristor is in anti-parallel. So the most important to this circuit is that it gonna transform AC voltage to another AC voltage but controller. The next slide. Well, here we can see that our fire angle is 75 degree, and we can see each pulse about the thyristor. Now here we can see the gate one, and the angle is 75 degree, and each pulse is there is an offset of 6 degree, and the amplitude of each pulse is 120 degree. As we can see, between the pulse 1 and pulse 2, there is an offset 60 degree, and between the pulse 2 and pulse 3, is the same. So this gonna be the same for each pulse. The next slide. Well, now we can see in the V load, as we can see at the beginning, and at the beginning the voltage from the thyristor 2 and 5 2 and 5 doesn't work. At the beginning, just only work the thyristors the thyristor number 6 and the thyristor number 5. So at the beginning only work this thyristor that I mentioned before. So only work the pair of thyristor from 6 and 5. The next slide. Well, here we can, as a resume, we can see the each gate. For example, at the beginning we have the gate number 1, and sorry, the gate for the pulse the thyristor 4 and 5, and how between each phase there is an offset of 6 degrees, and the amplitude of each phase is 120 120. And the next slide.
Well, so we now I'm going to talk about the output voltages analysis, and here I will separate each phase voltage at the load. Phase 1 voltage is in a red color, as we can see. At the beginning, we can appreciate the offset of 15 degrees, where Q4 and Q5 are on. They are in a conduction mode. Then where can we find the firing angle? So in the phase 1 voltage, as my partner talked about recently, so here we have 75 degrees. Then we can see the pattern of the repeating sequence. So for phase 1 voltage, we have the firing angle, and then we can see two positive peaks of the sinusoidal signal, and we can appreciate that each pulse width is about 60 degrees. Then the thyristor number 1 is off, and then we can repeat the sequence. So thyristor 1 is again on, and we can see that now it has two negative peaks. If we analyze the phase 2 voltage, is similar to the phase 1 voltage, with the difference that we can have a offset respect to the phase 1. So it's the same sequence, two negative peaks, then off, and then two positive peaks. It's interesting that we can appreciate that the voltage we can see at the load is never the neutral line voltage. It's always gonna be the line to line voltage. So we can have aquí comparison table. We can see the voltage AB over 2 and so on. So the form of the voltage, it continues the pattern. And finally, the phase 3 voltage is similar to the phase 1 and to the phase 2, but with another offset. Is first 2 times is on, then Q3 is off, then 2 negative peaks, and so on. And finally, the output currents, we can see in this chart that it's have the same waveform signal, since we are treating with a resistive load. So currents and voltages will have the same form of the signal. In the yellow color, we can have the current of the line U. In blue color, we have the line of the current of the line V. And in orange color, we have the W line current of the load. So we have here the harmonic analysis of the line current. In this case, we analyze the line A current, so it's similar for the another lines. And we have the bar, a bar graph. So first of all, we can see the DC component. It's the fundamental 60 Hertz, and it has 11 volts of amplitude. Then, as we learn in theoretical with our lectures, we don't have even harmonic. And finally, the third harmonic with its multiples don't appear too. So we have the fundamental component, then the fifth harmonic, then seventh harmonic, and so on. Here is the 11th harmonic, and we can see that pattern. So we have here the Simulink with our circuit, and we analyze the THD with this tool of Simulink, FFT analyzer, and we can appreciate what I talked about recently. And the THD is about 43.39%. It's not a good THD, and it's because the waveform form of the current. So this is the analysis of our circuit with the 3-phase bidirectional AC-AC controller. Thank you.